In this video, I will show you how to use a choice analysis or logistic regression analysis to determine the impact of different marketing factors such as price, promotions, and so on the consumer choices. For instance, whether the customer joined a company or not. And this type of analysis will use the past behavioral data. And please remember, the outcome variables only have two choices or two level, yes or no, or 0 or 1. Okay. So in this analysis, we will use the dataset TKL. And before we begin, could you please load two relevant packages? The first one is the OpenXLSX to save the output to the Excel file, and the other one is ggplot2 and for plotting purposes. All right, so let's run the first codes. Cool. Next, on this slide, could you please run this one? And when we run this one, we will have a new window, basically the program asking us which data set we want to use for this type of analysis. So we need to choose the relevant data sets. In particular, in this case, that is the acquisition data set. Because our goal is try to run the acquisition choice model. All right, so if you see in the environment, we already successfully loaded the dataset with 2000 observation with 8 variables, right? The next one, what do you think we should view in these plans? So we just save the dataset in the object TKL-A, right? So we just mention again the object TKL-A, right? And if you run the code, you will see the data structure on the screen right now. In the first column, we have the variable acquire. That is the outcome variable. We have two levels, 0 and 1. 0 means the customer was not acquired. 1, the customer was acquired. And we have several predictors such as price, quantity, delivery time, sales support, industry, firm size, buying center. If you would like to know what are they about, you should read the case description and the variable descriptions. All right. Now we can do some initial exploration. We can check the column names of the data set. So we can use the names function with the object TKL-A, right? So right here, we can see all the names of the columns. We can use the summary function to check some basic statistic of each columns. And we keep repeating the name of the object that we saved the data to, right? So right here, you can see for each column, we will see some basic stats. Or we can use the structure function to explore the structure of the data set, the column types, the number of rows. Okay, TKLs, the A's again, right? So for instance, we can see 2000 observations, 8 variables, and we see the type of the column that is integer, right? And we see the first few values of each columns. All right, so there's one step is quite important. That is converting the scientific number to regular number format. What is that? Basically, in the logistic regression outputs, most of the time you will see a few scientific notations. Okay, for instance, like this one, 2e minus 0.5. What does it mean? So if we do this step, we can convert the scientific number like this one to a regular number format. And let's run the code. Okay, and Yeah, we already converted from 2e minus 0.5 to 0.00002. You will see this step is important later on when you analyze the output of logistic regression. Now, it's time to run the logistic regression. And to run logistic regression or choice model, we should use the GOM function. If you want to learn more about this function, you can ask for help and you can read the relevant documentations. Okay. So basically, to use this function, we should have the formula of the output of the outcome to the sign and all the predictors in the dataset, or the relevant predictor that you want to insert into the algorithms. Okay. So what do you think we should fill in the plans right here? Okay, basically we should specify the predictors we want to put into the algorithm. Okay, you can see these are the predictors. So the first one is price, right? The second one is quantity. The next one is delivery time. The next one is sales support. And the next one is industry. The next one is firm size. And the last one is buying center. All right. And remember, the outcome is binary. So we need to choose a suitable family for this kind of regression. GOM is used for several general line linear models. So we can check what could be the family for this type of function. So the one we would like to use is the binomial here, the link equal to logic. So we should specify it should be binomial, right? I think we can run the code already. Good. Now, we restore the output of GOM function to the fit object already. We can summarize this object to see the output. All right, so we have the output right here. Before we begin to interpret the result, let me show you another way to write the code. If we use all the predictors or independent variables, okay, so in R, if we say the outcome, the tilde sign, and dot, basically we want to regress all the predictors on the acquired outcome. Okay, let's run it. And we have exactly the same outcome if we, specify specifically for each predictor. Right. Now it's time to interpret the result. Okay. So I give you some hints right here. It's good to read it. So you have four types of estimate. The first column right here, you have the coefficients. A positive coefficient means the predictor increased the likelihood of the outcome. In this case, that is the acquired. A negative coefficient means the predictor decreased the likelihood of the outcome. And larger absolute values of each coefficient indicates a stronger effect, a stronger weight on the outcome. A second column in the output, that is the standard error. The standard error measures the variability of the coefficient estimate, and smaller values indicate more precise estimate. The next columns, you have the Z value. Z value will be calculated as the ratio between the coefficients and the standard error of these first two columns. And higher absolute values of these Z values suggest stronger evidence against the null hypothesis, What is the null hypothesis in a regression analysis? The null hypothesis assumes that there's no relationship between the predictor or independent variables and the outcome dependent variables. So in other words, it's assumed that the coefficient of a predictor variable is zero, meaning it has no effect. And a higher absolute value of Z suggests stronger evidence against the null hypothesis, which means that there will be a relationship between predictor and the outcome variable. And the last column, you have the p-value right here. So you have different significant levels, okay? So it depends on the number of the asterisks. So generally, if p-value is smaller than 0.05, the predictor is considered statistically significant. And lower p-value indicates stronger evidence that predictor has an impact on the outcome. Okay, so I just give you some hints. Now, could you please analyze the result of the logistic regression? Okay, for the price, okay, so what you see, this variable is significant. So price has an impact on the acquired outcome, in particular negative impact, which means with lower price, the customer more likely to acquire the product and service of the company. The next significant variable is quarantine. And with this positive relationship, it means that if the quarantine period of the company is longer, the customer may consider to acquire the product and services. All right, the next significant predictor is sales support. Similarly, if the sales support from the companies is better, higher, then probably the likelihood for customer to acquire the company offering is higher. All right, let's jump to the firm size predictors. We also have positive relationship, which means that for those customer as a business customer, the firm size of the customer bigger, the more likely they will consider the company product and service. All right. There is one interesting variable called industry. All right, so what do you think about this variable, how we interpret the result? If you read the data description, you will see that industry is a categorical variable with three levels. One stands for construction sector, two stand for industrial sector, and three stand for the OEM sector. Then how we interpret this number is quite challenged, right? And again, how you interpret the coefficient, the weight, if you put the absolute sign for all these coefficients, you will see the weight from the industry variable is the biggest one. So this is the strongest predictor. All right. So to interpret the industry variable or predictor more appropriately, we have something to do further. First, let's explore the industry variable, okay? So let's use the table function to tabulate, to count the observation for each sector, each level of industry variable. We can type here industry, right? So we can see that we have around 650 observations for construction customer. We have around 1,000 observation for customer being in industrial sector and around 350 from customer being in OEM sector. All right. Now, with the original industry, it's quite challenging to interpret the meaning. We can't transfer each level of industry variable to a new binary variable, and we can use those new variable in regression analysis. Okay, so we can use the function if else. Again, if you have no idea about this function, you can use some help here. All right, and read the usage of the function. Right now, let's create a new binary variable called construction. Okay, so this function will look up all the value in the industry column, and if the value is 1, so it will return the true value 1 to the column called construction, right? If not, the column construction will have the value of 0. Next, we will create a new column called industrial, right? A new variable called industrial. Basically, this variable will look up all the value from the industry variable, and if any value is 2, then the function will return the true value, which means 1 for industrial variable. And if the value is different than 2, this function will return 0 for industrial variable. And similarly, let's create a new variable called OEM. The function will look up all the value from the industry variable. If any value equal to 3, the function will return the true value for the OEM variable. And the value from industry column different than 3, it will return 0 otherwise. And after we have the new 3 binary variables, remember, we should run the analysis again to interpret better the meaning of the impact of the industry and the outcome. How to do that? We can combine the original data TKL-A with the 3 new variable we just created above. Okay, so let's fill in the name of the 3 new variable. The first one is construction sector, right? The second one is industrial. And the last one is the OEM. So let's see if we type this correctly. All right, we didn't run these 3 codes, right? We need to run it before we can combine. All right, now we can combine ready. Okay, now let's check the column names of the new dataset that we call df-A. All right, so we have all the column names here, including all the original data from acquired column to bind center, and also included the 3 new binary variable we just created. Okay. Okay, if you want to view the new data, you can view df-A. Right? See, we have the binary value for construction, binary value for industrial, and binary values for OEM. Now it's time to run the logistic regression with the new data set. Okay, so that new data set is df-A, and we can use the dot represent for all the predictors in the data set. But look, in this data set, there's one variable seems not so useful for us to interpret. Remember, that is the original industry variable, so we can remove that column. We don't need it in this new route of running logistic regression. And to specify it, we don't want that variable. We can specify the position of this variable, which is 1, 2, 3, 4, 5, and 6. So basically, we should remove the 6th column in the new data set. So we can minus the 6, and we run it. Here we are. So we have the good result, right? Without the original industry variable, but we see the result for construction sector and the result for industrial sector. All right. Now, another challenge, how to interpret the coefficient for the construction variable and the coefficient for industrial variable. Okay, I also prepare some notes right here. Could you please read and try to interpret the result with me? So the industry variable is categorical. We already created 3 new dummy variable for each category, right? And the elastic regression, I mean the new one, we use one category as a preference, the baseline group. In particular, in this example, they use OEM as a baseline group. The NA here doesn't mean that OEM does not have an impact on the outcome. Okay, it just means that OEM acts as a preference point. And the coefficient of the dummy variable show the effect of each industry type compared to the preference category. So this variable implies the impact of the customer being in construction industry compared to customer being in preference category, which is OEM. So a positive coefficient means that the industry type increase the likelihood of the outcome relative to the preference category. So it means that the likelihood of the customer being in construction industry to acquire the product and service of the TKL company is much higher than the likelihood of customer being OEM sector to acquire the product and service. And likewise, we also have positive number between industrial and OEM. It means that the likelihood of customer being industrial sector will buy the product and service from TKL is higher than the likelihood of the customer in OEM to buy the product and service from TKL. And these two effects are statistically significant. All right. So some of you might ask, what happened if we remove the OEM column because it's just a preference point? So we can do that. We can check the position of the OEM column, which is 7, 8, 9, 10, 11. So the position is 11 in the data set. So we can regress all the predictors on the outcome. We can specify that here. And we should remove the column that we don't want, including the original industry and the OEM column, right? So the industry column is 1, 2, 3, 4, 5, 6. 6. Position is 6. So we specify 6. And the OEM column is 11. All right. Then we can run. So we get exactly the same result, okay? Just without the OEM line. So the elastic regression will consider the last level of the industry variable as a preference point, which is OEM in this case, okay? So in the data set, OEM stay in the last position, okay, of the data set. So this one will be considered at the preference point for construction and industrial. Now, some of you might have asked, what happens if we consider another level as a preference point? It's totally okay. And we can try it now, okay? So let's run the elastic regression again with industrial as a preference point. How to do that? We can move OEM forward and make the industrial stay in the last position of the data set. So let's run it again so we can regress all the predictors on the outcome acquired here. We specify the dot. And at this time, we should specify the order of all the column. All right, so basically we need all the column with except the industry, and we change the position of industrial and OEM. So acquire 1, price 2, quantity 3, delivery time 4, sales support 5. We don't need industry, so we don't need 6 here. We need firm size 7. We need buying center 8. We need construction 9. All right, now we need to change the position of industrial and OEM here. So we should put 11 and 10, right? And we can grunt. Okay, here we are. Okay, so we have slightly different result, but let's interpret it. Okay, so what does it mean when industrial as a reference point? So compare between the construction versus the industrial, the likelihood of the customer being in construction that acquire the product and service from TKL company will be higher compared to the likelihood of the customer being in industrial sector buying product and service from TKL. All right, now how we interpret this number, okay? So this number means that the likelihood of the customer being OEM buying product and service from TKL will be lower than the likelihood of the customer being in industrial sector buying TKL offerings. Okay, do you see something similar? So if you look at the previous result, 0.411. If we compare industrial to OEM, industrial higher than OEM. This time we see the number minus 0.44. OEM is lower than industrial. So the result is the same. There's no difference at all. It doesn't matter which one is the preference point. It's more matter how you interpret the result. Great. Now, let's do another extra step. So to confirm what we have discussed so far, and let's plot the predicted probability by industry category. So in this line, I will compute the predicted probability of the acquisition using the output from our logistic regressions. Okay, right. Now let's plot it using ggplot package. And we use the information from the industry variable and from the predicted variable we just computed right here. And we specify the label on X and on Y, and that's it. Okay, so right here, what do you see? We see industry 1 construction right here, right? We have industry level 2, which is industrial sector, and the level 3 is OEM. And we can see that the probability that customer acquire product and service from TKL between 1 and 2, construction will be higher. Between 2 and 3, industrial will be higher. Between 1 and 3, construction will be higher than OEM. All right, so we are good. All the analysis are consistent, for the insight that we can gain from. So we already finished the main step, how to run the choice analysis or logistic regression. Now, the rest of them, just about reporting and presentation. We already have the output from logistic regression. We can extract the 4 type of estimate: coefficient, standard error, z-value, and b-value. Basically, we just replay the order of each estimate column from the output to the blanks here. Okay, so coefficients from the first column of the output, the standard error, the second column of the output, the z-value, the third column of the output, and p-value, the last column. So how we know that? You see, coefficient, the first one, standard error, second column, z-value, third column, and b-value, the last column. Okay, don't forget to run the code. Okay, we already extracted those important estimates. Now let's store those estimates in a data frame. Okay, so basically we just mention the object we store the estimate. Okay, so the first one is coefficient. Good. The next one, standard error. The next one, Z value. And the last one is P value, right? Now, see, if we view the data frame we just created, it looks much more beautiful compared to the original output from the logistic regression. Now, it's very neat, easier to understand and interpret. And the last step, don't forget to save this table to the Excel just for further analysis in the future. So what do you think we should fill in here? That should be the data frame object, right? Estimate. Okay, you can go to the File tab and see if you already got the estimate.xlsx file. All right, so I just demonstrate how to use the code on one dataset, acquisition dataset. Could you please try to replicate the analysis for expansion choice model? Exactly the same, but remember, try to use the correct dataset. Okay.